Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. So, a day before the email scheme, whatever you want to call it. So the Andrew McIntosh guy. So there's a little bit of a conversation about, yes, it'd be nice to have the experiment done, tug of war, nice and simple. And of course, the excuses start getting made. Okay, so Andrew McIntosh says, this has been said before. So what has been said before? Okay, conventional science predicts that neither object will win the tug of war. So you're just conceding the argument that this energy is meaningless and useless because it really won't show up in any even contest. And, I think there is a way to, there's got to be a way of doing the experiment where you can show us your kinetic energy doing more work. So, I mean, it's just ridiculous that you're basically arguing that it'll never work. It never will show it has more energy, but it has more energy. Is what he's saying, which is just bullshit. So, equal momentum. The force transmitted through the string, well, I didn't say it's string, but okay, that connects both objects will depend on the relative momenta. So this doesn't mean anything. Yeah, of course. It's going to depend on how much force the two objects are capable of manifesting. Since the momentum are balanced, neither object wins immediately. What does that even mean? In terms of pulling the other in one direction. Well, clearly the thing that's stronger and bigger in a tug of war wins. So, I mean, we've all seen tug of wars, and you could say, yeah, okay, they have a 400-pound guy over there, and this guy over here isn't going to be able to move the 400-pound guy, so he's going to lose. However, kinetic energy differences play a role in the dynamics. So this is this fake word of somehow the dynamics. It's everything is dynamics. Everything is something interacting with something else. The argument is that if it has 5 times the energy, you should be able to see it in the dynamics. The one mass object has more energy to dissipate, which could manifest as. So this is more, it could manifest as something, but it won't in any experiment you do. So, and he's saying that's okay. If it doesn't manifest in the experiment, it means it didn't manifest in the experiment because it didn't manifest in the experiment. It's just this bullshit excuse that, it's somewhere, but I'm never gonna prove where it is. Great ability to strain and break the string. So where did you point out any of that? Where did you show any of this string breaking shit or any of that nonsense? The longer duration of oscillation and vibration. So there's absolutely no evidence that one vibrates or oscillates more than the other one. So again, more nonsense. If the string is inelastic, which doesn't make much sense, but okay. Obviously it'd be rigid then, but okay, fine. And perfectly transmits force, the system will eventually settle to a shared velocity where momentum is conserved. There's no system going to do anything like that. The two objects are going to hit the rigid fact of the force against the force, and they're both going to just go like this. They're going to, it's all going to be reflected force. It's going to be in there. They're not going to just stop. No one thinks, they just stop. No, they don't just stop. Okay, the one mass, it either crushes something or it bounces. There's only two choices. You either crush or you bounce. Okay, the one mass object's higher kinetic energy doesn't directly mean it wins. So again, just more nonsense. It doesn't mean it shows that it has more energy. Oh, okay. Because momentum governs the immediate dynamics in this case. So what's the point of this? If momentum always governs, then what's the point of kinetic energy? If momentum's the only thing you're going to see in an experiment, if it's the only thing that's going to move the rocket, why are we talking about kinetic energy as meaning anything? If the string stretches or absorbs, so again, more vague notion that somehow the energy went into stretching something or doing something. You have no evidence that if I take 2 of the same exact cars and do the experiment, and then I change the one car, make it 5 times lighter, but I make it go 5 times as fast, that there's any more strain on the string. You're not proving any of that nonsense. The higher kinetic energy of the one mass object result in greater displacement and deformation. Of what? Where? So again, more fake notions that something was displaced or deformed, and they have zero evidence of any of it. All right, so neither object decisively wins because momentum is balanced. So go ahead, show me where the physicists say that. Yes, kinetic energy will never be collected, it'll never do work, because momentum is balanced. Okay. However, one mass object's higher kinetic energy gives it the potential to cause more dynamic effects. So this is more baby talk. The wrecking ball has the potential to create very dramatic effects in hitting a building. Fact, and the bullets have very little effect in terms of their energy getting dissipated into the building. Okay, such as increased strain on the string. So again, he's saying it again. Somehow he has evidence that the string is more impaired and stretched and aggravated or heated, if I change the shape of the momentum. So if I make it a 5 mass going 1 velocity, or I make it a 1 mass going 5 velocities, somehow the string will know the difference. Okay, before the system comes to rest. So just absolute crap. So it's almost like, yeah, what's the point of proving it? Because the proof doesn't mean anything to these people. And that's sort of the point, because the point, we already have the proof. The lever proves it, and rockets prove it. So those two things are absolute proofs, in my opinion, that this is all nonsense. So I'll just illustrate that one more time. So then he goes on, all right, and to bring up the free momentum experiment. So again, so at least that one, we know that's conclusive for this guy anyway. So I guess if we're going to do one of these experiments, the free momentum experiment's the one to do. Although this may look like decisive proof that kinetic energy is not real, there are other conflicting experiments that take momentum equals energy into consideration. So again, the only conflicting experiments are rackety experiments. First, we have air tracks that are all over the place. In terms of, Brozo made 3 of them, and none of them worked. I made one, it didn't work. And Professor Lewin had to put clay on his. So we have a really messy air track experiments. And then I've already explained how springs work. So the carts launched by the cheap spring, yeah, that's really easy to explain. Springs don't give as much energy to lighter objects, just a fact. The spring retains more energy the lighter the object you put in front of it. Just an absolute fact. Okay. And I made a whole video just devoted to that, just called springs, and it just points out exactly the defect in using springs to give energy to objects, because you won't give them the same energy unless you apply a lever as a interpretation device, as Brozo did and demonstrated. The pendulum collisions with balls, unequal masses of momentum, is energy. Then all these collision experiments are basically free momentum generators. So he's making my point. The pendulum collisions with balls, unequal masses. If momentum is energy, then all these collision experiments are basically free momentum generators. Yes, exactly. Yeah, that's what you're saying. And obviously I'm contending that's nonsense. You can't make free momentum. So let's do that one. If momentum is energy, then 1 mass going 2 eV equals 1 mass going 1v. Yes, exactly. That's what the lever demonstrates. And rockets demonstrate. This means that when you launch a 1 mass and a 2 mass with the same energy input, yes, let's do that. With the same energy. That means you actually give the object twice the velocity. The 1 mass should go twice as fast. It will go twice as fast if you use a lever. However, numerous experiments have shown, numerous experiments have shown that levers work perfectly good, and they will do exactly this. You can put a 2 mass, 1 distance, and a 1 mass, 2 distances, double the velocities, and those two things will be indistinguishable. You won't be able to tell the energy difference of creating those two objects. The numerous experiments have shown that the 1 mass only goes approximately 1.4 as fast. So it's just a lie. There aren't numerous experiments. Big, fat, disgusting, hairy lie. Okay. Which is a prediction of the kinetic energy formula. So there's no numerous experiments, and he clearly didn't link to any. So this is all just talk. He just talks about what physics says. He doesn't cite any professor saying this crap. So I don't see any professor saying, yes, I'll concede something with 5 times the energy won't win a tug of war with something that has the same momentum. So even though it has 5 times the energy, it won't win. I haven't seen the professor who says that. So he ought to show us the goods. All right, so we'll just go over all these dopey experiments and try to get somewhere. So I was thinking, maybe there's some way to do an experiment where, you have a reliable, something not like a spring, way of launching things. So compressed air is probably better. I haven't thought through any potential flaws in it, but we're just looking for. I don't believe that's working. Yes, we have to fix that. All right, should be good to go. All right, so it'd be nice just to get it into some kind of rocket kind of scenario. So look, this is the obvious one. Okay, it's just obvious that kinetic energy is bullshit because it can't do this simple task. Okay, so if I have two identical rockets, and I just say that one of them's going to shoot, one mass objects at 2v, well, let's use the 5-to-1 because that's just so dramatic. Oh, Jesus. Can you see any of that? No, you can't see any of that? That is bizarre. All right, we'll fix that too. All right, well, it's a little better. Anyway, should be much better, but anyway. So out of one of them, they're going to be 5 masses going 1v, okay, and out of the other one it's going to be 1 masses going 5v. All right, so this one has 5 times 5 times the energy. Okay, that's what their theory says. And so if we just shoot out these 2 volumes, which will take the same energy to push these 2 things, and that's just an absolute fact. This one's not going to go 5 times as fast, and so they're conceding the argument. If I calculate the kinetic energy, it's not going to mean anything, because the only thing that's going to matter, the only thing that's going to move the spaceship is the momentum every single time. And that's going to work. So I'll get the same motion out of the ship because I have the same momentum, and it's the momentum that obeys Newton's third law. So it's sort of an absolute experiment, just proves the case. And so you're just trying to find some way to engineer this experiment in the bounds of Earth without screwing it up with some crappy variable that makes a mess out of the way you're creating this opposite reaction. So I could think of a way of, I think it's fair enough, okay, is that you put a little launcher, okay, with a spring, okay, that's going to shoot things. And the catch is that you have to obey the law of the lever, in the sense that you have to put the 5 mass, close, and you have to put the 1 mass 5 units of distance further away. And therefore you'll duplicate the ratio of 5-to-1, and the lever will move exactly, the launcher will move exactly the same speed. So the speed of the swing of the arm will be exactly the same for both cases. So you're sort of ensuring it's the same energy because you've got exactly the same motion in the stick, so to speak. All right, and the spring's going to expand at exactly the same rate. So you'd have to argue, if the spring's expanding at exactly the same speed and it expands exactly the same amount, that it's the same energy that you got into both objects. Is there any way to make some other argument? The spring expands at exactly the same speed, and it expands the exact same amount, and I'm going to argue that somehow it's a different amount of energy. So that seems unlikely. So anyway, so I'll end up with the same scenario. I'll have a 1 mass going 5 velocity and a 5 mass going 1 velocity. And the fact is, they say that in the one case I've created 5 times the energy. Okay, this is 5 times the energy, the light object moving fast. But what will I get in terms of motion here? I'll get exactly the same amount of mv. I'll get the same velocity in both cases. So one case it's 25, it's 5 times the energy, and yet I'm going to get exactly the same motion. It's 25 times, right? Yeah, it's 20. Yes, no, 25 times the energy. Jeez, I underestimated it. That's what they say. No, it must be 5 in this case. Yeah, if it was the same mass, then it was 25. Okay, so yeah, 5 times. All right. I mean, it's more than enough to prove the case that it's not going to go 5 times as fast. It's not going to demonstrate that this kinetic energy thing has anything to do with reality. No, let me just pause. It just seems so insane to say 25, but yeah, well, that's really what it says, right? I mean, if I do the calculation, it's 25 times the energy. No, 5 times is right. Anyway, clearly it won't happen, okay? Same momentum. You're not going to get 5 times the motion. You're going to get exactly the same motion. So again, that experiment seems to me, how can he argue when this result takes place? That is, that the cart doesn't move any faster when I launch the lighter object, and the lever itself all moves, all these mechanical parts move exactly the same speed. The only thing I change is the speed of the object leaving the lever. So how can that experiment in any way be argued to have hidden kinetic energy power somewhere? Like somehow I deformed or displaced or did some sort of dynamic thing that somehow absorbed the kinetic energy, and therefore the kinetic energy couldn't show itself because somehow I broke it. There's just no way around it. So this experiment should work. So you should be able to say, yes, okay, if you do this experiment and it comes out with the same momentum, obviously kinetic energy is bullshit, right? I mean, you have to concede, right? yeah, I think you have to concede. All right, so I mean, Brozo did a version of this experiment already. Now, he didn't do it perfectly, but, you know, the results were rather dramatic. So, I mean, the idea is you have the same spring, you're going to expand the same amount of distance, and you're just going to launch something that's twice the mass in this case, and 1 mass over here, and you're going to get twice the velocity, which he essentially got in 1v for this object. And so it shows that it works as a principle. No 1.4 anywhere, nowhere close to 1.4. Okay, very close to 2 to 1, especially if you're watching it. You know, it really looks like 2 to 1. But anyway, and so what he needed to do was put little stops on here, because obviously the part of the lever, it's going to be, you know, the further out you go, the more distance it's going to travel connected to the lever, and the more likely it is it's going to slide in a direction. And so you want to stop that from happening. So I would argue that, you know, Brozo lost a little bit of the lighter masses energy because he didn't have a stop on there to force it to not slide further out on the lever. Because it really is important that the speeds match for the spring to be going the same speed. And that's ideally what you want, is you want it to be exactly the same motion for the lever, so all of the variables of the lever are taken out of the experiment by changing the speed. And so I've got, I mean, I guess I should just point out very quickly, this is the spring argument. So, I mean, launching things with springs just doesn't work in terms of putting equal amounts of energy, and it's, you know, it's a rather dramatic difference. So if I have a 2 mass and a 1 mass, the fact is the 1 mass leaves with a higher velocity. That means the spring is moving at a higher velocity. 2 mass leaves at a slower velocity. That means when the ball leaves the spring's moving slower. Okay, you know, 1/2 the velocity, and so obviously the spring has less energy still in it. The momentum of the spring is less because its velocity is lower. So when the object leaves, the spring has less energy still in it, where the spring in this case is still moving very fast. So when the object leaves, it can't push it anymore. The spring still has a lot of momentum still in it. So you can't use springs to give different mass objects the same amount of energy. It won't work. And that's why you use a lever to change the scenario, so you can make the same motion, the same exact motion of the lever, okay, into 2 different velocities. So I can create the 2 different velocities on a lever. You can almost see that arrow. Anyway, and have the spring and the lever itself move exactly the same, which means they have consumed exactly the same amount of momentum. So you have ensured that there's no place to mess up the experiment by I can't get that to work. All right, so the other experiment is this idea of banging. We'll just stick with the 3 mass just because we know that's a very doable. So you have a 3 mass and a 1 mass, okay, and we're going to use a pendulum to hit the 3 mass. And my argument is I'm just going to put these 3 masses under a tiny bit, numerous ones, and I'll have them under a little bit of pressure from, say, a spring. So they just push into each other. As you knock one out, the next one pops in. You knock that out, the next one pops in. So, and I'm just going to create a pendulum here, and I'm just going to swing it with a known amount. So we're going to put 100 momentums in. All right. And their theory is that when this hits the 3 mass, it's going to create 150 momentums going out in the 3 mass. And then the next one comes in, and this one will go back with 50. So I've got 50 still going back up into gravity, and it's going to come back down again. So I can use it again, and this time I'll have 75 momentums, because it's 50 hitting 3 mass, which means I'm going to get half again more momentum. So I get 75, and then I'm down to, I'll just get a rebound that will be half, so that'll be 25. All right, I can do it one more time, okay, and I'll get whatever it is, 35 or something. All right, so that's it. We'll just stop there. So I've got a total of 250 momentums, and I only put 100 in. So that's their theory, that this actually will happen. So if this experiment is done, and the truth is found that this isn't going to happen, okay, you're not going to get 150. You're going to get 75 and 25 is what you're going to get, because you can't make more momentum. Direction has nothing to do with it. There's no such thing as a negative direction of motion. Motion in the universe is always positive. There's no such thing as subtracting motions. There's no such thing as unenergy. So you can't put 150 energies this way and make unenergy that way, and somehow it's only took you 100 work. 100 energies can't make an explosion that creates 150 and 100. Can't do that. Can't happen. Impossible. Okay, simply. So this will be the experiment to have done. Is just to prove that no, I can't multiply my momentum in a direction. I can't make something more and more powerful. Because obviously I could just take all of these things and do the same experiment all over again. I could take that 250 and apply it to a lever and convert it into a 100, a 1 mass object going 300 momentums, 250 momentums. So I could put it back in and have it make even more energy the next round and the next round and the next round. So I could just keep creating more and more free energy, because I'm creating free momentum. And you can't make free momentum in this universe. So that should be an experiment where he doesn't have an out. That if this experiment is done well, there's, this should be, there's no way around it, right? There's no theoretical way he can escape that this is what's going to happen. I'm going to create more momentum. I'm going to get half my energy back, and I can do it again and get more momentum. And then we'll get half my energy back, and I can do it, get more momentum. There's no way to argue around it that he's saying I can more than double the amount of momentum by just hitting some heavier things. And the heavier I make them, the more extra momentum I'll make. So, obviously I could change these numbers to 199 and 170, and so I could make it 10 times the momentum by just making the object heavier, make it a 6 or a 9 mass, and I can make even more free and momentum. So it's obviously a nonsense theory. They're not gonna pass this test. So if they do this test, it'll prove the case that momentum is not directional. There's no such thing as unmomentum or negative momentum. There's just mass moving in the universe, and that's all that matters, is how much mass is moving. That has to be conserved. You have to conserve the amount of mass moving. All right. So I think that's enough. Probably. I'll take a pause and think about it for a second, but I think that's enough. All right. Thought of an interesting, just a little tidbitty part. So the launching car with the lever spring idea. The interesting feature is that when it's at the launching position, the top, okay, you could argue that this is a one, you have a one mass. I did 1 to 5, right? Right. So, but let's just say we did 1 to 4. Well, anyway, the distance thing. Well, anyway, so it's the whole argument about the 1 unit of distance for the 4 mass versus the 1 mass 4 units of distance. But the interesting thing is if I was to drop a 1 mass 4 times the distance, it's twice the time. And in this case, it's only going to be 1 unit of time. So that's the interesting trade-off, is that you move the 1 mass, even though you need to make them equal in terms of the energy, you need to move the 1 mass 16 times the distance. That's what makes them even. But that's because of the time thing. So now that I've changed the time that it's going to take for me to get it to that position, I'm in the gravity less time. So it's less work against gravity because I'm moving it faster than the speed that I would have to launch it to get it to stop at that height. So I've changed the dynamic because I've changed the fact that it's not going to fall or rise at twice at 1/2 the velocity. It's going to be moved at the same velocity. Therefore, it's not going to be in the gravity long enough to be the full amount of energy necessary, blah, blah, blah. So it's going to be the same in the end. So anyway, it's just an interesting curiosity that you can the gravity portion isn't going to be the natural falling velocity or the rising velocity. It's going to be quicker than stopping at the velocity necessary to get to that height and then stop because you're launching it. So anyway, so the argument's still valid in the sense that it's not an argument against it. You can do the experiment horizontally to get rid of all of those problems. So you could just create the car if the car was this way. Wrong pen here, right? Yeah, this one's not as good. Okay. Little wheels here. And you did the launcher with a spring here and then 2 levers. Okay. And then through your objects, obviously the cart would have to be big enough to hold the objects. 5 masses in close, 1 mass is out 5 units of distance. Then you get rid of the gravity scenario, and it's it's not going to be an issue. So anyway, that would be another way of doing it, and proving the point that this will actually be twice as much energy because I have 2 levers. Right. Well, I have 2 of these too, so it's still only twice. It's still only 5 times. It's not 10. I have to think about that. Twice. Yeah, I'm moving 2 5-pound objects, and I'm moving 2 1-pound objects, so it's still the same thing. But anyway, so it'll just prove the case. So you do it the one time with the 5s in close. You leave the lever the same length, obviously, so it's the same mass that you're moving. So the system consumes the same energy in both cases, and that's what you want, a system that consumes the same energy in both cases. And so the rest of the energy is just the launching energy. And the fact is, their theory says it should go 5 times faster, when I have the little masses than when I have the big masses in close. And the fact will be is that it'll go exactly the same velocity both times. So that should be a pretty decisive experiment, frankly. Prove the case once and for all. I don't think he can come up with any gimmick to get around that one. So, till the next time and such, and so forth and whatnot. Yeah, it really should be enough.